Hello everyone, this is my project to demonstrate the efficient ingestion, storage and analysis of logs. We have a solution to ingest these logs efficiently. As we all know, a humongous amount of logs are produced by complex systems every day, and it is very important to store these logs efficiently and analyze them. To demonstrate this, I have taken two sources for logs. One are the direct HTTP endpoints where these servers can post their logs through the REST request. Another are the microservices which produce different kinds of logs and put into our Kafka queue, which are then pulled via the Kafka SDK into our log ingestion. This log ingestion service is built using Golang and Gin. We chose Golang because of its highly efficient and very high throughput provided by the Go routines. The Go routines are very lightweight, and the primary purpose of the language was this lightweight threads. So we have went with this choice. We put the logs that we pull from Kafka as well as the HTTP endpoints into the buffer. This buffer is important because the number of requests of logs is very high compared to the number of queries that our database can handle. As a result, this buffer helps to save them into the local available memory, and we pull the logs from this buffer, put it into batches and bulk insert into the database so that we don't flood the database and overload its queries capabilities. As a database choice, we have chosen ElasticDB due to the efficient search as well as different filters provided by it inherently, as well as the sharding capabilities it involves as it is a NoSQL database. Next, we have the analysis engine, which is used by our web application to query the logs using this search and various filters. We have regex as well as normal text search, as well as filters for specific fields involving different fields, as well as the timestamp ranges. To demonstrate this, I have created a web service which is running in this terminal, as you can see on the port 3000. Now to demonstrate the producers for our Kafka, I have created different terminals. Let's move to that. We have these different terminals demonstrating the different Kafka producers. We can assume this as the microservices. Let's run each of them. Now these are producing logs at 1 second intervals and are being consumed by our ingestion service. As you can see, different workers are working on different threads to process these logs and inserting into the database. Let's refresh, and yes, we have a lot of logs already. Let's close this publishers. Okay, this is the Kafka engine. Now let's move on to the performance test. This is a script I've written to demonstrate the flooding of humongous amount of logs, which will be used to demonstrate a real life scenario. For this demonstration, I have only put 3000 logs, but it can scale even more, especially when we add more resources. So let's run this, and as you can see, a lot of logs are being flooded onto our service, and until the script had completed, only 1700 were ingested, rest are still in the buffer, and by now it should already be in process. But yeah, as you can see, all logs are not immediately processed, they are put into the buffer, and yes, 3000 entries we already have. We can also see the logs over here. Now let's move on to the web UI. This is our web UI. Let's refresh. Okay, so our web UI provides us with various fields such as level, message, resource IDs, parent resource IDs, etc. There are different levels with different tags. As you can see, we also have a metadata with different fields. The parent resource ID is an important field, so I have put it over here as a separate column also, just for visualization purposes. We can use various kinds of search available here. Let's go for text search. We can search for any text and it will search across all the columns. As you can see, we have logs having disk, word. Let's search for something else, API. We have APIs. Now let's see the regex search. So let's see those logs starting with email. So these are the logs that start with the word email. We can also sort this data table. Let's remove this for now. We also have different kinds of log levels, such as error, info and warning. We can sort them. Let's filter only error logs out and maybe info logs. So okay, these are the info logs. Let's add error logs. So it queries only these two logs for now. We can remove this filters for now, and we can now see the date filters. We can put a start date. Let's put something from 2021. We haven't put any end date for now. Let's see which logs we have got. So it starts from 2021 second month, and if we sort in descending, it's 12th month of 2023. Now let's put an end date, maybe 2022 August, and yeah, now the August is the last month that we see. Now let's search by message. So this is only for the message column. We can put multiple searches for any column, any filter. For example, this shows us the logs having messages, having words, server as well as email. Any of them works. Let's search by the parent resource ID present in our metadata 9876. As you can see, it has filtered out the parent resource IDs with 9876. Now 1234. You can see both are available. Additionally, we also have resource ID. Let's search for this resource ID. We can put any combination of any of these filters. We also have filters for trace IDs, pan ID, which we can utilize similarly. Similarly for metadata, you can leverage any of these filters across the database. Now let's talk about the future improvements. So these are the improvements that we can bring into our project. First is Kibana integration, so that we can have a visually appealing analysis of the logs. Next, we have persistent or WebSocket connections between the servers, which are the log producers, and our ingestion service, so that we have a lower latency ingestion possible. Next, we can also implement a redundant disk buffer, so that if our log ingestion service goes down, we have the logs which were in buffer available, so that when we spin it up again, we can put those in the database reliably. Next, we can also implement an alert system to notify the system administrators or users about the critical logs that happen in real time, so that the timely action can be taken and our business thrives. So this was my project. Thank you.